Good day all of you. In a previous video we have discussed about the solar cell. That we have discussed that solar cell are made up of silicon in as a non-conductor or insulator, and that silicon cell is a smaller unit, and the series are connected to of at least 36 cell, and that is called as solar cell. And then that number of means up to 100 solar cell make one panel, and during the preparation of that panel, the solar cell are connected in series or in parallel way. If they are connected in series, then their voltage will be constant, and current will be added, and if they are connected in parallel, then their voltage will be added and their current will be constant. That concept we have discussed, and we have also discussed that if you require to generate more amount of energy, then we have to use such more panels. Means panel to panel will be connected to create a bigger unit for the production of more energy, and each cell is having the capacity of 15%. Means if we consider the 100% solar energy is coming on the cell, then out of which the 15% will be only converted into electrical energy. But in that case, one thing is there, that electrical energy which we are getting from the solar cell is DC. DC means the direct current. Direct current means as and when light is coming on the cell, it is getting converted, but as the source is cut off, then electricity will also be cut off. That is known as DC, direct current. The power available from solar cell is DC. But so in application which need DC power, like electric light based on light emitting diodes, the energy can be directly used. However, since the energy from the solar cell is available only in the presence of sunlight, the energy has to be stored in batteries for the use at later time. Direct current means we have to utilize as and when we are getting it. We cannot store it. But our appliances which we are using is not working on direct current. They all are working on alternate current, means AC, short form of alternate current. So we have to store, or we have to convert this direct current into AC current. So how we can convert? By storing this direct current into a battery. When you are storing this direct current into the battery, automatically this current is converted into AC current, that is alternate current. And by connecting the wires of the battery to some instrument, we can use that energy. However, the most of appliances or equipment in the domestic as well as industrial use run on AC. AC means alternate current. In case of DC, solar power must be converted to AC power using an electronic device called inverter. Inverter is one of the instrument which is used to convert the DC into AC. You have all have an inverter at your home, and that inverter is connected to some battery. Means it is that inverter is working reversible. Means it is taking the power electric current and storing it into the battery. Understood? But here we have the role of inverter is different. That is, it is converting or storing the power from the sunlight into the battery. That is vice versa. Little change in home inverter and inverter at this solar plant. So the one inverter is required to generate the electricity. So your diagram or flow chart of solar cell is like, from solar cell the energy will be transferred to battery or better or battery, and battery will connected to inverter, and then inverter is connected to your appliances, so that inverter is converting the battery DC current into the AC current. So this is the flow chart. Now, we have seen that many solar panel can be connected together to generate whatever energy we need. As it is shown in the figure, you can observe that lots many solar panel are connected in parallel also and in series also to generate much amount of solar energy. And the DC power generated from this panel is first converted into AC power. You can observe that there is inverter and transformer which is first converting the DC power into AC power, and then it is been transferred to the power grid for storage. Then a transformer, the voltage and the current level of the generator power, and then it is fed into the electricity distribution network. That is what they want to say, कि one inverter or transformer is required to convert the DC current into AC current. In this way, the electricity is generated without any fuel combustion and so without air pollution. However, since the energy is generated using solar radiation, solar cell can generate electricity during daytime only. Now, this is the drawback, that only in daytime we can generate the electricity. Now, for overcoming that problem, we has one more another type of plant, that is solar thermal power plant. We have seen that thermal energy generated from coal and nuclear fuel can be used to generate electricity. The thermal energy can also be generated from solar radiation and can be used for electricity production. The different stages in solar thermal power are shown in the figure. As we have used coal to heat up the water to generate the heat energy, so that water will be converted into the steam. Likewise, we have used nuclear energy to generate the heat energy to boil up the water and to get it convert into the steam. Likewise, we have also utilized natural gases to heat up the water. Natural gases were directly giving the high power of another gas after burning or after combustion, and that gas is forced on the turbine. Likewise, for heating up, we are using the solar panels to heat up the steam or to heat up the water in the boiler. So their schematic diagram is this, that concentrator for collecting the sunlight. This is the solar panel which can concentrate the sunlight. Then absorber for absorbing the concentrated sunlight, means the boiler will be placed on this plate which is absorbing the sunlight. Then the water will be heated up and steam will be released, and then steam will be forwarded to the steam turbine. Then steam turbine will rotate, and it will rotate the magnet or a conductor in the generator, and then the electricity will be generated. So, this is utilizing the induction, electromagnetic induction principle only. Likewise, as shown in the figure, many reflector reflects and concentrates solar radiation on absorber, and this solar energy is converted into heat energy. Using this heat energy, steam is generated to drive the turbine and the generator. This is the schematic diagram for solar thermal power plant. Understood? You can observe that these are big solar panel who are absorbing the sunlight. Then they are being with the absorber is there, and that absorber the pipelines are there in which the water is there, water is heating up, and the steam is being only released through the pipeline, and that is running the turbine, that is steam turbine, and then generator, and then it is being collected in the grids. That is the schematic diagram for solar thermal energy plant. You should focus on all the diagrams related to the particular power generation plant, because question may arise by showing the diagram and asking few questions related to that diagram below that, means which type of plant is this, on which principle it is working, what type of flow chart it is following, and which type of energy is converted into which type likewise. So you should focus on the diagram. Though you don't want to draw the diagram, you won't be there, but it may be there to label the diagram. So please focus all the diagram properly. And here in the yellow chart they have given that which type of fuel we are utilizing in India and how much percentage we are utilizing. So we are utilizing maximum coal, so we have to reduce that utilization as it is been hampering our environment. So we have to generate more renewal procedures, or we can find out some more procedure in future to reduce the uptake of the coal. So this is the end of your chapter. Now I am requesting you to kindly complete these exercise questions in your notebook. This is your first work. Okay. Have a good day.